Pepcoding. So the question which we will discuss today is called minimize malware spread to. So we've already discussed the first part of this question. So if you haven't watched the video for that question, please go and watch it so that you can understand the basics of this question properly. So moving ahead, let's understand the question first. So you have been given a network of n nodes represented as an n cross n adjacency matrix graph, where ith node is directly connected to the jth node if graph of I and j is equal to 1. That means you have an adjacency matrix called graph, and if the ith and jth position holds the value 1, then that means that the node I and j are directly connected to each other. Okay. Some nodes are initially infected by malware. Whenever two nodes are directly connected and at least one of those two nodes is infected by malware, both nodes will be infected by malware. That means that if 1, 2, and 3, which are directly connected to each other, and 1 is infected by malware, then since 2 is directly connected to it, so 2 will also be infected. Then 3 will also be infected, and this will go on. Okay. Suppose this spread of malware will continue until no more nodes can be infected in this manner. Suppose initial is the final number of nodes infected with malware in the entire network after the spread of malware stops. Okay, so that means that this is the final number of nodes which we have in the network which are infected after the spread of malware has stopped. Okay, we need to remove exactly one node from initial, completely removing it, and any connections from this node to any other node. So this means that we have to remove exactly one node from initial. All right. Now in the previous question, what we did was we were disinfecting that node. Okay. Now in this question changes that we have to remove this node completely along with all of its connections, that is all of its edges. Okay. And we have to return the node that, if removed, would minimize m, and if multiple nodes could be removed to minimize m, then return a node with the smallest index. All right. Okay. So basically over here what is happening is, let's suppose this is my graph. All right. 0, 1, 2, 4, 5. Okay. Now this is my graph. So in case, for the previous question, what we were doing was that in case 0 was infected, we were simply disinfecting it. Now I need to remove 0 and its connections completely. For 0, it is very easy, but suppose I have to remove 1. So I'll have to remove 1, I'll have to remove its connections also, and it will separate the graph into components. So now the problem is that, let's suppose I had some other graphs over here, or some other components of the graph over here. Then if 0 is infected, it will infect its whole graph. 6 being infected will infect its whole graph. 9 being infected will infect its whole graph. So I have to make sure that I have to minimize or remove the node. The removal of which node can minimize my spread of malware or minimize the number of values which I'll be having in initial. Okay. Now if you were thinking that we can make a graph with all of these nodes, then remove the node which is being infected, then make the graph again, divide it into components, remove all the edges. It is possible, definitely possible. It will be very hectic and it will be a tedious task for you to do. I think that the solution of that is that you can simply create a graph without the infected nodes, right? See, over here I have initial, right? And in initial, let's suppose I'm talking about the uth element. So the uth element is present in initial. That means it should not be added to my graph at all. So it will not cause me any risk of having the other nodes being infected. So I can remove u easily. And then let's suppose it has v connections. So I can remove those connections also very easily. I will not add them to the graph. It will make things very easy for me, right? So let's understand this with the help of code, so you will be having a better understanding of what we are doing over here. I'll just keep it over here only. Now see, what I've done is I have copied the parent and size matrix. I've copied the find function which we created in the previous question. Okay, and I've also copied the merge function which we created in the previous question. Alright. Also, I am bringing from the previous question this part. Okay, what is this part? where I was initializing parent and size, and I was putting nodes into the graph. Now, what I need to do is that in the graph, I have to make sure that I will not add those components which are already present in initial. So over here, let us create a hash set. Okay. And this hash set will contain all the elements which are present in initial. So hash set of integer. Okay. Let's name it set. So for int e in initial, over here, I just missed something. Set dot add e. Alright. So now my hash set is ready. What I'll do over here is that over here in the condition only, I'll make sure that set should not contain I and it should not contain j also. So set does not contain I and set does not contain j. Okay, this will make my graph. I will not add the nodes which are being infected, and I will not add the connections also. After that, I'll just tell you what we are going to do after that. Over here, I have my nodes, right? I need unique parents. For example, if I'm working with the US row, so having one at any position, I and j, means that those two nodes are connected. So let's suppose I have 0, 1, 1, 1 and I'm working with the third node. The third node is connected to second node. It is also connected to first node. And let's suppose 0, 2 and 1 are also connected to each other. Now, I will not be able to have a unique parent in this case, right? So I need to make sure that I have a unique parent for any group. Let's suppose over here also, this is a separate group, this will be a separate group, and this will be a separate group. So I need a representative for these groups, and the representative for these groups will be the unique parent of this group. The unique parent will be the parent of all the elements of the group, and it will represent the group. Let's suppose I had 6 over here. Okay, so this in itself as a whole would have been a group, and it would have a unique parent with which I had to work, and I will add only that parent. So over here, we can create a hash map. Okay, in this hash map, I will have integer values. Along with that, I can create a hash set. Now this hash set will contain all the unique parents. I'm taking a hash set so that I have all the unique parents. Okay, and let's name it map. Okay, then I am working for int u in initial. Alright, in initial. So the first thing I'm going to do, I'm going to put this to the map. So map dot put u, and along with it, I need a new hash set. A new hash set of the type integer. Okay. After that, we'll work for int j is equal to 0, j is less than n, j plus plus. Okay. In this, I am going to check that if graph of u comma j is equal to 1, right? And u is not equal to j, and the set should not contain this element. So set dot contains j should be false. Okay, only in this condition what I'll do, I'll find p first. So int p is equal to find n. This will help me find the parent, and I'm going to put this onto the map, right? But now see, over here what is happening is that let's suppose I have the unique parent, the count of parent becomes 2, right? So if I remove 5, 5 and 0 have common parent, right? So if I have 5 and I remove it, then 0 will be able to infect the rest of the graph. If I remove 0 and leave 5 on the graph, then 5 will be able to infect the rest of the graph. So I need to make sure that the count of parent is 1 only. For that, what I'm going to do, I'm going to create, let's say I am creating an array of integer type by the name of infected. Okay. And over here, I create a condition. What is the condition? See, if map dot, if map dot get q dot contains p. That means in the map, I should not have this parent. Okay. Only in that case, I'm going to put this parent in the map. And I'm going to increase the value at infected of p. Okay. Otherwise, I'll do nothing. After that, I need to work with answer, which will be -1, and max, which will be -1 as well. Okay. Then I'll start working with all the initial elements. So initial, and in this I'll create a hash set. Why the hash set? Hash set will have my unique parents, and these parents I've already created in this hash set over here in the map. So I will just create a hash set and let's name it parents, and I will get it from map. So map dot get u, and I need a total value. So total will be equal to 0. Okay, now I'm going to work with all the parents. So for each int parent in the parents hash set, if the count of parent is 1, that is, it is unique and the count is 1, only then I will add it to the total. So infected of p equals 1, only then total will be plus equal to size of p. Okay. After that, the next thing which I am going to do is I'll exit this, and now I will check that if total is greater than equal to max, and also if total becomes equal to max, then the value of answer will be minimum. So math.min of answer and u, right? Otherwise, answer will be equal to u only, right? Now I got the value of total and max, and max will be initialized as total, right? So this part also we've done. Now I need to check that if at the end also answer comes out as -1, then I need to return the minimum value. So if over here I'll work with this, that if answer becomes equal to -1, then in that case what I need to do, I will create a min variable, give it the maximum value. Okay, and for int e in initial, I am going to assign min as the minimum of this min and e. Okay, and lastly I'll return min, and if answer is not equal to -1, then I'll simply return answer, right? Okay, so this is the code for the question. Problem is that we are still working on the test cases for you, so I will not be able to run this code for you. I'm hoping that since we've already discussed the question and its logic as well as the code, so now you're capable enough to code it on your own. Soon enough, you will be able to run it on the portal as well. So please have a little patience as well as a little faith that this code is correct and the logic which we've discussed is correct. Okay, so keep practicing by yourself, and we will see each other in the next video. Till then, please like, share, and subscribe. Thank you.